So let's start the practice. This is a very basic question I have taken for jet propulsion questions practice. So you guys have to solve all the assignments as well and test series as well. So but one or two few questions you should see the way I am approaching. In that way you have to approach the tougher questions, and of course you have to keep asking your doubts from assignments and test series. So by this Saturday and Sunday you guys finish all 20 questions of jet propulsion what I have given assignment. Let's go with the question. So question says, determine the outlet temperature and pressure for a turbine whose purpose is to power the compressor. So it means I have to run the compressor, so that I need a turbine. So we have to find out the exit conditions of turbine. So data is given. So compressor inlet data is given as 280 Kelvin and 80 kilopascal. So you know that to run the compressor you need turbine. Okay, so here we have combustion process in between of compressor and turbine, you know this. So at the inlet of compressor, in my notebook the way I am teaching the notations, you have your pressure and temperatures. So you have P02 pressure, T02 temperature, and at the exit of compressor you have P03 pressure and T03 temperature. Then after combustion, when combustion gets over, that happens at isobaric process. So whatever pressure P03 is here, that pressure will be P04, but value will be same. P03 and P04 will be same because isobaric process. And after combustion temperature will go high, so T04 will be more than T03. So we will understand how to calculate T04 also. Then they have given data when the flow will pass through the turbine, then because of expansion this pressure will decrease, so we'll be having P05 pressure and T05 temperature. Okay, so this is what our nomenclature is, and what they are asking, determine the outlet temperature and pressure for a turbine. So it means our job is to calculate P05 and T05. These both data we have to calculate. So let's go ahead. Compressor efficiency is also given. Compressor exit temperature means T03 is also given. Turbine inlet data is given. Turbine inlet means immediately after combustion. So it means what? You don't have to go for the fuel air ratio formula to calculate T04, because T04 is already given. So T04 is done, and P04 is also given. So you can check one more thing. This compressor exit pressure is 400 kilopascal, and turbine inlet pressure is also 400 kilopascal, which is the proof what we have learned in our class. Combustion happens at isobaric process, isobaric condition. But one more thing, I have told you that there can be losses 2 to 4%, but right now those complications are not given in the question, so this question is simple. Okay, now next part is how will you go ahead in the question. So very easy job. Whenever this pressure ratio is given, which is P03 by P02, because P03 value is 400 kilopascal, so you write down 400 kilopascal and divide by P02 is 80 kilopascal, so you write down 80 kilopascal. Okay, and you cancel and you solve. So compressor pressure ratio is 5. Okay, now using this compressor pressure ratio, using this given efficiency, I also taught you in class, if efficiency is given as 78%, in the formula you have to write 0.78, right? So you remember I gave you one formula. In that formula your equation was it's like pressure ratio formula for the compressor. You remember what I gave? 1 plus efficiency of the compressor, that was isentropic efficiency, then work done of the compressor, then Cp T02 for the compressor, whole power gamma by gamma minus 1. You remember this formula we have done. Now using this formula you can find out this work done. Okay, because if you are looking for work done, then this work done you will connect with the turbine work done, because I taught you regarding transmission efficiency. So right now transmission efficiency is not given, so W compressor will be equal to W turbine. Okay, now in W turbine turbine is connected between 4 and 5. So Cp for the gas, T04 minus T05. This equation I have given you for the W turbine work done. Okay, so if you know compressor work done and T04 is already given in the question itself, T05 I can calculate if I know compressor work done and turbine work done. Anyway, they both are going to be equal in this question. So use this pi c, use this efficiency 0.78 which is given, use CP value for the air 1005 because any special value is not given. So by default value 1005 SI unit, and gamma value 1.4 you have to take. So then if you do so, then you will be finding out your WC, and after finding out WC, equate in this equation, you will be finding out T05. Okay, and you can reshuffle the equation. Actually efficiency is missing here. Okay, so T05 you got. It means how much data you have now. It means at the turbine, at the inlet, data is given. It means P04 is given, T04 is given. You can check here. Turbine inlet, T04 and P04. Turbine inlet is 04. That is given. Okay, and just now we have got T05 by comparing work done. So once T05 is done, then you can apply here again turbine efficiency formula, and you can find out your this pressure, or you can directly apply the isentropic part and you can again find the pressure in case of ideal turbine. Okay, but because turbine efficiency is given, so ideal turbine concept will not work. You have to bring the efficiency in the turbine case. So very simple. See, if you are, guys, why I am solving this question from the fundamental, because in case if you are forgetting any formula, you can connect the formula easily. Okay, like this formula I wrote, but even though you must have capability to derive the formula from the TS diagram in case you are missing. But anyway, if you are missing the formula, you are already out of the war GATE exam. Okay, any student, I don't expect that you are forgetting the formula. No, your first tool is the formula. Before that, of course, concept is there, but you have to be good in everything, concept and formula, everything. Now, how did I teach in turbine case? In turbine case, this was your P04 and this was your P05. Sorry, yeah, correct. So now suppose this is your temperature. This temperature is on TS diagram. I'm solving this. This temperature is your T04. So if you'll come ideally, then it is going to be T05 dash, but in actual case it is going to be T05. But because isentropic efficiency is given for the turbine, it means this is your real case, actual case. Okay, so from here, if you write down efficiency formula, so efficiency for turbine, if I'm writing, how will I write? You know my concept, gap concept. I taught you, right? Gap concept. T04 minus T05 divided by T04 minus T05 dash. Okay, so this T05 dash and this T04 will help you to get the pressure value. So you do one thing, divide throughout by T04. Okay, you can divide this by T04. So take T04 common from here, take T04 common from here. Or anyway, if you know turbine work done, then from here no need to take T04 common. You do one thing, efficiency for turbine, you can write this as, in this you multiply CP and divide CP. You can do that. So when you multiply CP, that will become work done for the turbine, and the division wala CP will come below here. Okay, so I'm writing WT divided by CP, and in bracket this T04 I'm taking common, T04 I'm taking common, so 1 minus T05 dash divided by T04, right? Fundamental is important, otherwise you'll do mistake. Then what you do, this part you can replace with the pressure, correct? How? T05 dash by T04, T05 dash and T04, this is T04, they are falling on isentropic line, so this you can write as P05 dash divided by P04 whole power gamma minus 1 by gamma. And you know this P05 dash is nothing but P05, because this line isobaric line, right? So all the points are giving same value. So P05 dash you can write as P05. So P05 divided by P04 gamma minus 1 by gamma. Now point is, this W turbine is nothing but W compressor, and here you have got W compressor, correct? So this data is known to you. Turbine efficiency is given in the question itself. CP value used for the air 1005. T04 turbine inlet temperature. Turbine inlet temperature is already given in the question itself. Turbine inlet temperature here. Okay. Now you can use P04. P04 is also given in the question itself, and now you can develop P05 from this formula, right? So what how will you replace this formula? You have to exactly here in the bracket, you have to switch this value, P05 by P04 whole power gamma minus 1 by gamma, and everything is given. You can find out your P05 easily. So now you guys will do one thing. When you guys will solve, because I am not solving, I'm not giving you data. I can solve and I can give you all the answers, but why I'm not giving you answers? So that you will solve, and everyone in the WhatsApp group, you guys will write down the answer, so that everyone will understand that they are doing wrong on this one is doing wrong, that one is doing wrong. And if you're watching this video public on YouTube, even you guys try to write down all the values in your comment box, so that even others can match. I hope this concept is clear. If any doubt, just after class or before class, you can discuss with me, okay? Or guys, you can also, like in the group, you give me the whatever is your doubt, I'll solve this. I don't think you will be having any doubt here, okay? But see, why did I take this question? Because this is the smallest question. Anyway, you have to solve a entire jet propulsion problem. Like in last class, I taught you question number 9, right? In that everything was given, diffuser data, compressor, everything was given. And I will take one more problem now after this.